So in this next example, this investigation thing, notice that we have a table, and I told you that in tables, generally, not always, but generally, the first thing they give you is the independent variable, otherwise known as the x, or list 1, and the second thing is the dependent variable, otherwise known as the y, and if we're going to use our calculator, we put it in list 2. And in the first question, step 1, it says, how do we determine the variable that's independent, and which one's dependent? So the big idea is they'll always ask you a question like, what is this? And in the statement up above, they say, I want you to look for the amount of time. Whatever they ask you to find is the dependent variable. Whatever they ask you to find is the dependent variable. That tells me that I know that my dependent variable is going to be time. So time is my dependent variable. This is what I'm looking for. Which means then, of course, that I know that my independent variable has to be, sorry. The number of people. Or in other words, the x stuff. Questions about that? Okay, so now it says, let's assume that this stuff can be modeled by a line. So we put these things on a graph, scatter plot. Looks like the dots kind of line up for the most part. We're going to make some predictions. And I want to make a line. So in order to use our equation that we were talking about earlier, which was this y minus y1 equals m times x minus x1 thing, this point slope form of a line, recall that this thing is talking about that you have a slope and that you have some point. That's why they call it point slope. So anytime you want to do that, you need number 1, a point, and number 2, a slope. So in order to do that, we're going to calculate the slope of this line. So let's calculate the slope. I can pick any 2 points that I want to calculate the slope. Sophia, which one of the number of people values do you want to use? 6. Okay, so I'm going to look at the 6th one. That's one of the 2.
22.
And then 22. Thanks, Fashan. So I'm going to find the slope based on those 2 points. You could have picked any of them, because we're going to assume that this stuff is linear. I just randomly picked those 2. I don't really care. Doesn't matter as long as I pick 2. So now I calculate the slope. If I calculate the slope, that's y2. So the second y value that was picked was 11. So my slope equals 11 minus my first y value, which is 5.2, divided by my second x value, which was 22, minus my first x value, which was 6. So on the top, I believe I get 5.8. And on the bottom, I get 16. And then I need to divide these 2 things and go to the nearest decimal place. 2 decimal places, that is. So if somebody could please divide those for me. I know it's less than 1, so it's point something. 0.36? 362? All right. So to 3 decimal places, 0.362. That's the slope. 0.362. The next question asks us about the y-intercept. The y-intercept. So in order to find the y-intercept, I can use any method possible. When I hear the word y-intercept or the phrase y-intercept, I think of myself slope-intercept form of a line. In case you don't recall about the slope-intercept form of a line, that was when we had the y equals mx plus b. And the b is the y-intercept. So I found my slope. That slope, 0.362, is the m value. And I can pick any point from the table to find the b. So I'll pick maybe the first one in purple, since we've already used it, plug in the numbers, and see what the b is. If I do that, actually I'm going to use a different one, just for fun. I'm going to use the first point, 2 and 2.1. So my y value from there, from the very first point, is 2.1. Uh-oh. I do that a lot, sorry. So 2.1, which is the y value, equals my slope, which was 0.362, times my x value from the first point, which was 2, plus b. So in case you're not following, this 2.1 came from here, it was the y value. The 0.362 was the slope that we calculated. And the 2 that I got was also from the table. And all I'm doing is I'm plugging these numbers in to find a b value, or in other words, the y-intercept. I could pick any point. I already know the slope, 0.362. I know that I can pick any of the x and y values from the table. And now I can find my y-intercept. So I solve this equation. If I solve this equation, I have 2.1 equals 2 times 0.362, which is 0.722, no, 0.724. Somebody check that out for me.
0.724.
Thank you. Plus my b value. Subtract off 0.724 from both sides, and you find out that your b value is 1 point something?
1.372.
376. So I solved that equation for b. And this is saying, what is the real world meaning of this 1.376? So it says we're supposed to estimate the amount of time needed for 100 people to do the wave. So this B stuff is talking about time in seconds. So this value is talking about, if I want the real world meaning, that 1.376 seconds have gone by when the wave starts. Meaning 0 people have started, nobody's gone up for the wave yet. 1.376 seconds. In part 4, we're supposed to come up with this equation, and it says, remember, if I'm going to do it in point-slope form, that I need a point and I need a slope. I already know what my slope is, and we happen to pick the first point, which was 2.1 when we started plugging in data, but we also chose the purple and the pink points. Remember, you can choose any point you want to. Your equation will look different than your classmates, but they all do the same thing. They predict a value. So our equation, based on what we just did,